Today, we're talking about one of the solar system's biggest celebrities, Halley's Comet. It only shows up every 75 or 76 years, so if you blink, you might have to wait nearly a lifetime to see it again. This comet isn't just a frequent traveler, it's also a space-time capsule, carrying secrets from the birth of our solar system. It has a truly explosive personality, leaving a trail of gases and dust wherever it goes, much like a rock star leaving crazed fans in its path. Grab your telescope, and let's embark on this cosmic journey to learn more about the amazing Halley's Comet. Edmund Halley, a renowned English astronomer and mathematician, made a historic discovery when he recognized that the appearances of comets in 1531, 1607, and 1682 were not isolated events of different bodies, but rather the periodic reappearance of the same comet. Using historical records and applying the laws of celestial mechanics formulated by Isaac Newton, Halley analyzed the orbits of these comets and noted a remarkable consistency in their periods and trajectories. His analysis led him to predict that the comet would return in 1758, a prediction that not only challenged the common ideas of the time about comets, but also established a new paradigm in celestial understanding. Halley did not live to see his prediction come true, as he passed away in 1742, 16 years before the comet's forecasted return. However, his contribution to astronomy remained influential, and when the comet reappeared in the night sky of 1758, as predicted, it was a monumental triumph for science. This event not only validated Newton's theory of universal gravitation, but also solidified Halley's legacy. In honor of his achievements, the comet was officially named Halley's Comet, becoming the first comet to be recognized as periodic. Halley's Comet, known for its spectacular periodic returns, follows an elliptical orbit around the Sun, which is fundamental to the predictability of its appearances. This orbit not only determines the 75-76-year cycle between each visit, but also describes a trajectory that extends from inside the orbit of Venus to beyond the orbit of Neptune. This means the comet travels through a vast range of distances from the Sun, experiencing huge variations in temperature and solar radiation, which directly influence its activity and visibility from Earth. The earliest known records of the comet date back to 240 BC and were documented by Chinese astronomers. These records are invaluable as they offer detailed descriptions of the comet's features, such as the direction of its tail and its trajectory in the sky. Moreover, these chronicles often associated the appearance of comets with significant events or omens, reflecting the cosmology and superstition of the time. Over the centuries, Halley's Comet has been observed and recorded by various cultures around the world, including descriptions in Babylon, ancient Greece, and the Roman Empire. These records not only confirm the comet's periodicity, but also illustrate the advancement in astronomical understanding over time. For instance, the Greeks and Romans began to develop theories about the nature of comets, which were initially seen as atmospheric phenomena and later as celestial bodies. The ability to observe and document the same comet repeatedly over centuries helped pave the way for Halley's future identification as a periodic comet. In 1986, the scientific community had a unique opportunity to study Halley's Comet up close, taking advantage of its predictable passage near Earth. For this purpose, several space missions were launched, notably the Giotto mission by the European Space Agency, ESA. This mission represented a historical milestone in space exploration, as it was one of the first times a space probe was specifically designed to pass close to a comet and send detailed data about its structure and composition. The Giotto probe was equipped with a variety of scientific instruments intended to analyze the comet's core, its dust, and the gaseous environment around it. In addition to Giotto, other missions from different space agencies, including the Vega 1 and Vega 2 probes from the Soviet Union, the Suisei and Sakigake from Japan, and the IC, International Cometary Explorer, from NASA, were part of the so-called Halley Armada. These missions were coordinated to take advantage of different aspects of the comet and maximize data collection. International collaboration allowed for a comprehensive approach, with each probe exploring different components of the comet, from gas analysis to capturing high-resolution images of the core. The Giotto mission, in particular, brought about astonishing discoveries. As it approached about 600 kilometers from the core of Halley's Comet, the probe faced a hostile environment, being bombarded by high-speed dust particles. Despite substantial damage, the probe managed to transmit incredible images of the comet's core, revealing a surface darker and more irregular than expected, covered in dust and with gas jets emerging from more active regions. These observations were crucial for understanding the physics of comets and the processes that occur on their surface as they approach the Sun. Halley's Comet, on its journey through the solar system, leaves behind a trail of debris composed of dust and smaller particles that have been released from its surface due to interaction with solar heat. When Earth passes through this trail of debris in its own orbit around the Sun, these particles enter our atmosphere and burn up due to friction, creating luminous spectacles known as meteor showers. Two of these meteor showers, the Eta Aquarids in May and the Orionids in October, are directly associated with the debris left by Halley's Comet. The Eta Aquarids, which usually occur between late April and early May, offer one of the best opportunities for observers in the southern hemisphere to witness meteors. This meteor shower is known for its speed, with meteors entering Earth's atmosphere at about 66 km/s. The location of the radiant of this shower, near the constellation of Aquarius, gives the event its name. Observers can expect to see about 40 to 70 meteors per hour under ideal conditions, peaking around May 5th. On the other hand, the Orionids, which peak around October 21st, are visible to both hemispheres, with the radiant located in the constellation of Orion, hence the name. The Orionids are equally fast, also traveling at about 66 km/s, and are famous for their brightness and occasionally leaving persistent trails. Although this meteor shower usually produces about 20 to 30 meteors per hour during the peak, the spectacularity of the fireballs makes it one of the most awaited showers by astronomy enthusiasts each year. Halley's Comet is a true space rock star, which, despite being darker than coal, continues to illuminate our sky with its spectacular appearances. But don't be fooled by its dark surface, because inside, it is rich in organic material, ice, and dust, making it one of the most studied and beloved comets by scientists and space enthusiasts. Now, here's a thought for you. We'll probably have to mark a cosmic rendezvous in our calendars for 2061, for the next live show of Halley's Comet. It's an event you don't want to miss, because, let's be honest, it's a party that only happens once every 76 years. So, who knows? Next time, in addition to observing, we might send a new generation of probes to take some selfies with this dark icon of the solar system. Don't forget to like and share this video if you're also counting the days to this next stellar encounter. And subscribe to the channel so you don't miss our next explorations through the universe. Until then, keep looking at the stars and wondering, what else is out there? Thank you very much for watching, and remember, space may be dark like Halley's Comet, but there's always something bright to discover. Until next time.